You checked it.
So stress like because it convert.
It's just like who?
Yeah.
Oh my god, I saw him in the fire and I thought it was him at first. So he did a good job.
That's so funny. That's really funny.
It's his birthday.
Oh.
I went to 4 thrift stores last night looking for a jacket. This little group of quizzes, like this little group of quizzes might be the best set of quizzes I've ever graded.
Oh.
Did you guys cheat?
No.
You're generous.
Like,
Anyone ever say cheating?
what? But it would have had to be like a giant cheating conspiracy. Like
We're all
finally
like-
you've seen like one of those
We're all
movies.
just like
where,
right away walking and off.
Yeah. What? We've done that to you multiple times. Did I ever give you yours?
Yeah.
Yeah, that's what I thought. Oh, Lord have mercy. You're good.
She's like, you did.
You should have just put in.
She's like, I checked the new ones. I don't think she's like
Yeah.
Windows. Like, we always
So literally. Like, I don't even have to give you the answers because I mean all but like 4 people total got 20 out of 20 or higher. I'm not kidding. Crazy. And the people that didn't got like 18s. So I mean I'm just thrilled. Like, so hopefully you didn't cheat. But yeah.
How did the next class do?
So I'm talking about everybody. That's what I'm saying. Everybody, not just you. It would have had to have been a giant conspiracy.
Nicole said that you told them they're smarter than us.
That's not
What?
Yeah. In that one instance, they were because I know what it was because I asked them a question that I asked you guys, and you guys all looked at me like I had 6 heads, and no one. And I asked them, and like they're like, "Whoa."
Oh, it's the question.
I don't remember.
Did ask me what it is.
Yeah, I don't remember what it was.
We don't really. We don't
Yeah. I don't remember. I really don't remember what it was. Okay, so do we have questions on the comparison test? I scanned those answers in the other day. I worked all those out. But you might still have questions after looking at those answers. So do you have any questions on that? Yeah.
On the limit comparison test for number 5, do we have like a sine or cosine? Do we just compare it with what is like next to it?
Okay, so when we were using the limit comparison test, that sine of 1 over n. Because the 1 over n was there, that's what I chose to use, like to compare with. Now, if I remember right, we started one in class on Monday or Tuesday or whatever day I last saw you. That was similar to that one. But we didn't actually get to the end, but it wasn't going to work. And we can maybe pick up on that here in a second. But so what was your question, Anne?
I don't know, like, I just, like, when I, like, went through it the first time, I didn't know what to compare it to. I didn't know if you had to compare it to, like, another sine one, or you could just do it.
Well, you could. I mean, you can compare it to anything as long as you know what it does. But like, I mean, the chances of you knowing what another sine one did is probably unlikely. So, like, you probably want to use one that you know. And I mean, just use 1 over n because it was there.
Okay.
We should probably go back and look at that one again. But other questions on this paper? Yeah.
Okay, so there's direct comparison and limit comparison. Can you always do either one of those? Or is it like is it like the rectangle square thing where you can always do a limit, but you can only sometimes do a direct? Is that what it's
Well, I mean, you can always do a direct if you can find a series to directly compare it to. I mean, because the requirements to use the direct comparison test, you have two things that you have to worry about. One, you have to know what the series that you're comparing to does. But with the direct comparison test, you also have to be able to show that the series that you're comparing to is less than or greater than the unknown one. And sometimes that's kind of hard to do. So you could, I mean, if you found the right series, you could do it. So I mean, you could theoretically always use either one of them, but they're not like, it's not like the rectangle square one where it's like, oh, this will always work for this, but sometimes work for this. I mean, I don't know that I would think of it like that. Yes, you do all shoes. With no spikes. 4 thrift stores, not one jacket. That was good to wear. These pants came from the thrift store.
Did the shoes too? Did you have
No, these shoes actually were, I mean, I used to golf in these probably 20 years ago. And just found them in my basement. So, the ties from the thrift store, this tie's kind of nice. Snyder bought 2 of these ties, $1 each. So, you know. But if you see him today, I wish him a happy birthday. No. Does that surprise you?
what did you say? 59?
Yeah.
It's hard to tell.
I know.
He has like a youthful personality.
And the thing about the crazy thing about him is I've taught with him my entire, like, he and I came to Fairmont the same year. He had taught 10 years, I think, or so at Sevens before he came to Fairmont. And I never could get out of him a straight answer how old he was. Like, how old are you? And he'd be like, I don't know. Like, he'd just say something. But he told Snyder this morning he was 59. So. Okay, other questions? So maybe we should look at that one. I made that one up on Monday, and now I'm worried it's not going to work. But let's see if we can figure it out. What was that one? It was
1 minus cosine of 1 over n.
It wasn't to the n or anything like that?
No.
Okay. So we were doing the LCT, right, with 1 over n. So and we know it doesn't matter which one you put on top, right? Okay, so as n goes to infinity, when I do this is, I mean, I'm going to end up getting cosine of 0, which is 1. 1 minus 1 is 0. 1 over infinity, 0. So I'm going to get 0 over 0 there, okay? So then we use L'Hopital's rule. So the derivative of negative cosine of 1 over n is sine of 1 over n times the derivative of 1 over n is negative 1 over n squared. And the derivative of 1 over n here is what? Negative 1 over n squared, right? Is that what you said?
Yeah.
Okay. I mean, who knows? We've got a mask on. Can't tell. All right, so that's the derivative of the bottom. So those would cancel, yes? So now we're left with this.
We did it the other day, we had it.
We flipped it, yeah,
Oh.
which is fine. The
Oh,
same,
that's
that
fine.
we're going to end up getting a similar result.
Is that not? So it's right?
So, well, no. So what happens here? You'll see. As n goes to infinity, what's that going to approach? Because the sign of 0 is 0, right? So this is 0. Okay? When we did it the other day, we ended up with 1 over 0, right? Which is approaching infinity. Agreed? But in order to use the limit comparison test, that limit has to be finite and positive. 0 is not finite and positive. Right? 0 is not positive. So the limit comparison test isn't going to work here. You guys see it, what I'm getting at there? So that's things. So how are we going to do this one? I might have to think about this. Should we try just something else real quick just to see? Like maybe a different series to use with the limit comparison test? Del, you say no? Why?
I don't know. Seems like a lot of work.
Yeah, we don't want to do that.
We do it again, but with 1 over n squared converges. Because this isn't that it diverges? Because 1 over n is divergent.
Right.
Yeah, so that was a test to see if I diverged.
Right, but the test failed. So it still possibly could diverge
Yeah.
because that test failed. So you're saying try 1 over n squared, see if the test doesn't fail with that.
Yeah.
That's a fair thing to try. I mean, now I don't know if I would say it's a lot of work, Adele, but like, I mean, like splitting wood for 8 hours, that's a lot of work. I don't know if this is a lot of work. So what if I do that? We still have 0 over 0, right? Everybody agree with that? So we're still going to have to do L'Hopital here. So what happens when we do L'Hopital? We end up with what's the derivative of the top? We already know it's the sine of 1 over n times negative 1 over n squared. And what's the derivative of the bottom? So that's n to the negative 2 in the bottom. So what's the derivative of the bottom?
N to the negative 3.
So negative 2 n to the negative 3.
Yeah.
Okay. Ooh, yucks. So we have to do some algebra here, it looks like. Put on your algebra pants. So negative 2 n to the negative 3 is the same as this, yes? So when I divide by 2 over n cubed, that's the same as multiplying by n cubed over 2, right? what's going to happen there, friends? What happens to these n's here? Those are going to cancel, yeah. And so we're going to have like n there. And I guess we're going to have a 2. So I'll just stick the 2 out in front. Right? Okay, so we ready to try this again? So now, what is happening as n goes to infinity? This is approaching 0, and this is approaching infinity, so we have 0 times infinity, which is still indeterminate. So how would we do this one? L'Hopital's rule again. But you got to write it in a way that you can use L'Hopital's rule as a fraction. So this is like this. Oh, I'm very excited. Isn't that the same thing? Algebraically? Now it's 0 over 0. Because when you rewrite 0 times infinity, you can rewrite it to get 0 over 0. Oh, so now we can do L'Hopital's rule again, yes? What's the derivative of the top? Cosine of 1 over n times negative 1 over n squared. And what's the derivative of the bottom? Negative 1 over n squared. And what happens to those? And what do we get? As n goes to infinity, we have the cosine of 0, which is 1 times 1/2. Hey! Finite and positive. There you go. It's a lot of work. So I would say that if we're using the limit comparison test and that kind of thing happens, like I would do it twice. Try it once. If the test fails, try something else. And if the test fails there, then the limit comparison test just might not work. It's possible. Okay. That was exciting. You know why that was exciting? Because it wasn't like I didn't know that was going to happen. I made that up on Monday because I knew on the homework was sine of 1 over n. I knew that one was on there. And so I made this one up, but I knew I had to make it, I had to put this 1 here because if it was cosine of 1 over n, as n goes, that would have failed the nth term test. So I put this 1 here. And then when we got this, and then Ellie pointed out as you guys were walking out the door, I was like, oh crap, that test failed. Let's fix that on Monday. But when you first made the suggestion to do 1 over n squared, I didn't see this developing the way it did in my head, like as I thought through it, like as you were talking about it. And I thought the test was gonna fail again, and I thought, oh crap, we have a problem that we don't know how to do yet. And then when I got here, as soon as I got here, when we were working it out, I knew this was gonna come back to 1. Did you see it as we were doing it? Did you know that was going to happen? When you got to sine n, or sine of 1 over n? Okay, well, so here's the plan. There's I think there's a 50-50 chance that I'm not going to be here a week from tomorrow. Okay? So I think that day we're going to have our first test for fourth quarter, and the test is going to be a test on tests. Does that make sense? Yeah. Like it'll be a test over all these tests. We have 2 more tests to learn. We're going to learn one of them today. It's actually the easiest one of all. It's like so easy. Maybe even easier than the limit comparison test. Because, I mean, I guess you could argue that once you've mastered the limit comparison test and the direct comparison test, you can pretty much just look at a lot of things and know what they do because you can see what they reduce down to. That's why the limit comparison test, that reducing rule works, is the limit comparison test. So we're going to learn the alternating series test today, and then we'll learn the ratio test, and then we'll have our test on test next week. So we may have one other quiz before then. Try to. But yeah. But for a day that I'm not going to be here is a perfect day to have a test. What if you're not going to be here on that day? We can figure that out later. Yeah, I'd say it's 50-50 for me right now. So, all right. Well, let's learn alternating series. So are we good on limit comparison and direct? We're happy with that. Sweet. I love it. I love it. So alternating series. Okay, so we'll kind of explain to what an alternating series is first. An alternating series is one that looks like this. It's basically when you have something that is generating a plus minus plus minus. Okay? And typically that's going to be some power of -1. Okay, there are other ways that you can generate a plus one minus one, which I'm going to let you kind of discover in the next day or two. But right now we'll just stick with -1 to a power, n plus 1. Now if we started that series at 0, that could have been -1 to the n. And honestly, it technically doesn't matter if the series goes minus plus minus plus minus plus. It's still alternating, right? So here's an example of just what an alternating series looks like. This is probably one of the most famous alternating series around. I think we've talked about this guy before. This guy right here. Okay? So if I write out some terms of him, he looks like this. 1 minus a half, plus a third, minus a fourth, plus a fifth, minus a sixth, etc. Okay? He's the alternating harmonic series. That's what he is. All right? Or she. So the question is what's going to cause an alternating series to converge, and what's going to cause an alternating series to diverge? Okay? It's real simple. An alternating series converges if and only if okay? So what is that saying? If the series is alternating, Okay, if the series is alternating, I'm not going to call this if and only if, I think. If the series is alternating, all right, and what is going to converge? What's the condition that needs to happen? The terms are going to 0. Okay? If the terms are getting smaller and going to 0, an alternating series converges. Okay? So, like the one I just gave you, that alternating harmonic, does he converge?
Yes.
He does. Okay? So he converges by AST. Technically speaking, alternating series is not a test, but we just call it a test. And on the AP test, when students actually referred to that as AST, they accepted that. So I mean, are alternating series difficult? No, not really. Okay, what makes alternating series kind of difficult is we're going to throw in some other another idea here. Okay, this series as a straight alternating series converges, right? We just agreed on that. However, this series right here that's an absolute value. If I actually took the absolute value of all the terms, what are you left with there? If I did this, that would be 1 plus 1/2 plus a third plus a fourth plus a fifth plus a sixth plus a seventh, yada, 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 right? Which is equivalent to this series right here. Correct? And what do you know about that guy right there? He diverges. Okay? So we're going to introduce this idea here of something called conditional convergence. It's basically saying that when you converge as an alternator and diverge as a non-alternator, we call that conditional convergence. Okay? When you converge as both, we call that absolute convergence. Right? So we're going to put that in kind of in words. Conditional convergence is basically this. If that converges, but let's just say it this way. We could just say that alternating is implied inside the A sub n. So if I take the absolute value of the terms and it diverges, but it converges when I don't do that, that's conditional. All right? And then absolute convergence is basically if the absolute value of the terms converges. Okay, for the most part, this isn't really that significant, honestly. The idea of conditional versus absolute convergence really isn't that significant, and it's not going to mean a whole lot to us. Like, we just pretty much are going to care whether it converges or diverges. Okay? What's kind of interesting, though, about conditionally convergent series is that you can show that a conditionally convergent series, you can rearrange the terms and make it add up to different things. Okay, now do you understand what I'm saying there? Like, for example, this series right here. Okay? This series right here. This is a conditionally convergent series, right? And if I write the terms out like this, 1 minus a half plus a third minus a fourth plus a fifth minus a sixth, right? That's one arrangement of the terms. But I can rearrange those terms and add them up in different order, in a different arrangement, and it could be shown that it adds up to something else. Okay? That's kind of whack. Because what rule is kind of being broken there? That's something you learn very early on in your life, in your like math days. I probably heard it. Commutative. The addition is commutative, right? Oh, A plus B is B plus A. Well, apparently not when you're adding up an infinite number of A's and B's. Okay? So I think it might be, would it be kind of fun to show you how this adds up to two different things? Would that be kind of fun to do? What?
I was shaking my head and then everyone else.
No, this sounds miserable. But before we do that, let's make sure we understand, like, if I give you a series and I ask you, and it's an alternating series, so you can recognize alternating series because you're going to have a power of -1 in there, like a -1 to the n, or a -1 to the n plus 1. Okay? A -1 to an odd power. That's going to make a plus minus, right? If I give you one of those and I say, hey, does this converge or diverge? What's the only thing that you really have to do to answer the question of whether or not it converges or diverges? Megan told you. She's like, see if what approaches 0. Right. If the terms are approaching 0, it converges. If the terms aren't approaching 0, it diverges. Easy enough. Okay? In fact, if the terms aren't approaching 0, you can say it diverges by the nth term test. Right? But if an alternating series terms are going to 0, then it converges. Like that, pretty easy. If we want to determine if it's absolute, what do you have to do? You have to get rid of the -1 to the n and see if that series will converge without the -1 to the n. And how are you going to do that? Use some other test. Use the limit comparison test. Use the direct comparison test. Use the integral test. Well, nobody likes it. Does that make sense? So like, okay, let me give you one real fast. Before we do this little conditionally convergent thing, because we can always do this tomorrow if we need to. Here you go, ready? Does that converge? terms alternating in sign? Yep. Are they going to 0? Yep. So that converges, right? Is it absolute or conditional? Well, we're going to have to look at this. And I will be okay if, when you are determining absolute or conditional, if you sort of do the hand wave test or the like what it reduces to test. Okay, if you're just checking for absolute or conditional, I'm fine with if you do that. So can you look at that guy right there? Can you look at that series? When I got rid of the -1 to the n plus 1, I took the absolute value of those terms, and tell me whether or not that converges to divergence. What does it do? Divergent. This is Collins' like sign language for divergent. Divergent. What is convergent? Convergent. That diverges. Why? Because it looks like 1 over n. It's going to do what 1 over n does. It reduces to 1 over n. Okay? So this diverges. So this is, or I should say this guy is conditional. Okay? What if I gave you this? Is it going to converge or diverge? Converges, terms are going to 0, and they're alternating in sign. Woo! Okay, so it converges by the alternating series. Is it conditional or absolute? So what we really got to do is look at this. Ooh. What test do we use for that? We haven't had one with a factorial in it before. Can't use the integral test because the factorial doesn't have an antiderivative.
You just do that.
Oh no, can you? What are the terms doing of that? The denominator is getting huge really fast. So that means the terms are going to 0. So can I use the nth term test there? Yeah. But we could use a comparison test. Because pick pretty much your favorite converging p series. 1 over n squared. Whatever. Just pick a converging p series. This guy right here. Remember, we said factorials just beat the pants off of polynomials. This guy is going to be way less than 1 over n squared. Maybe not the first 2 terms, but it's going to take maybe 2 or 3 terms and it's going to take over. Okay? Won't even be close. All right? So since this is less than that, what does this guy do? Converges. So this guy is absolument. Sometimes you say absolutely convergent or converges absolutely. That's why I said absolutely. Yeah, factorials, they just slaughter everybody. Okay? So here's what you're going to do. Tomorrow we'll blow our heads with rearranging numbers to show they add up to different things. So that's just calculation. You should see that in life. But here's our paper for today. Don't you just love getting papers? I love passing out papers. I'm kind of embarrassed. I can't, off the top of my head, show you that the alternating harmonic series adds up to two different things. I can't do it off the top of my head. I gotta refresh my memory. I'm really upset. I mean, I think I could figure it out, but it would take me too long to do it with
Do you
you.
take the sign or the sign goes?
No, you leave the signs the same.
Same, but somehow you-
Just rearrange it.
Yeah, but
We're not adding it back.
So it'd be like, instead of going like 1 minus a half plus a third, you might go 1 plus a third minus a half. Oh. I can't do it.
Because then we're gonna, for me, like, find that.
are we gonna go over, I know there was an, like, the answer to it. Are we still gonna go over it a little bit?
Yeah, if you have questions on it.
'Cause I'm still a little confused about what to do when something doesn't work.
They should all work on your homework. Like,
Well, I think it would have worked, but I didn't really know which function to use.
oh,
Two of them.
Yeah, what's the deal? Why are you matching with all the nice clothes? Like, super nice clothes. You're matching with Mr. Snyder.
but who are we dressed like?
Oh, him. Why?
It's Tip's birthday today. So everybody dressed up like this today.
Did Coach Baker dress up like this?
I don't know. That I'm not sure.
Didn't even like.
I went to 4 different thrift stores to find a jacket, and I couldn't find a good jacket, so I just used a regular old blue blazer. But these pants are from the thrift store. These are my
shoes.
the golf shoes.
These are your golf shoes?
These were my golf shoes. I don't really wear them anymore. I took the things out.
Oh, there's another thing.
Oh, okay. There it Yeah, these pants are straight from the thrift store, though. Well, I think I wore these I think we did this about 5 years ago. And I bought these pants for them. These are Hagar's.
I'm not.
Okay.
I have a game at 9:45.
I might not be here next Friday.
Really?
50-50. Yeah.
Are you gonna?
He just doesn't want to go. Yeah, he just doesn't want to be here.
I might be 50.
Yeah, you better take Billy and I.
I might be striper fishing more so like possibly. I haven't decided if I'm gonna go yet.
Yeah, are you taking like notes?
Yeah.
Okay, we should.
But it'll be live. You can always go back and watch.
Oh yeah.
And you can also. We can FaceTime if you. Oh, but you have a game right
Yeah.
What are we doing about the days of the match? You're
I don't know. It's upsetting me. When does that start? Tuesday?
Yeah.
I need to make sure I say something about that fifth grade or the last class tomorrow. I would really like to just have you come in and like we could just have a class like in the afternoon. Most of you are coming back anyway. Or not most, but a lot of you are coming back anyway for sporting events. Like on air test days, like you're coming to Fairmont in the afternoon for sports. Like that way, I don't have to make videos.
What time are we coming?
I don't know. Like we could do it like at 1, 2. And the air testing is over by like noon, so. What? Oh, here, bro.
Really don't. These next few days are gonna be really rough. We're down by 2.
Who got you up?
No, I'm not out, I'm still.
Who got the other guy?
It's me and one other person on my team. Three of our kids are out. Don't worry though. I have plans. I have plans for 2 kids. One of them is today.
What's Saturday gonna work?
Tomorrow is one also.
What time would you want to come back?
Let's do 1:30.
I mean, could we all come back and meet in one? Because I have 2 periods, right? So I mean, could we all fit in one period?
Yeah.
That would be fun. Hell.
But I don't think I could fit you all in here.
Yes, you could. We're gonna have to go to the auditorium.
Oh my, that would be
so cool.
We just had a whiteboard up in the auditorium.
Yes,
That'd be
please. Could we please do that?
For height, for slide hall. But then you don't have anything to write on. You don't have desks. That was the biggest mistake.
I'm fine with that.
With when we built that recital hall, that was the biggest mistake. Is not putting in desks that have like little or chairs that have like a little flip up thing. Biggest mistake about that. Because if we had that, this class we would have only been 1 section. Like we wouldn't have had 2 periods at Calc2. We would have just had 1. It would have been like a big lecture. Like. Because we don't, I mean, the number of students that we have in this, in BC Calc or whatever you want to call it, it's like 37. It's just too many for 1 section.
Are there a lot in the other class?
What?
Are there a lot in the other class?
Yeah, the other class, almost every desk is full. And you guys, this is deeply broken. So these quizzes that we took yesterday, which are right here, this might have been like the best collection of quizzes I've ever graded in my life. Like, I mean, all of both classes, almost everyone got a 20 out of 20, and only like 5 people didn't. And they got like 18s. I mean, or 19s. I mean, it was just crazy. Like, who's Alex? Is he quarantined?
Whole softball team is. I know, my dad came to my, yesterday, he was like, there's 42 people quarantined.
Yeah, what in the world? That's like more, there were more kids that are on that list as being quarantined yesterday. There were more that day than almost the entire sum of all of them for like the past 2 months.
It was like the girl on the softball team, like, either didn't know to take over, like, didn't tell people. So then, like, the whole team got
But the softball team's not 42 kids.
I know.
Is
And
it
the
like-
men's volleyball team was quarantined. Yeah. But they're like out of it. No. I don't know.
Where's Nicole?
Oh.
She was here this morning.
Oh.
Okay, so I don't even really need to go over this. The number one mistake on this was the sum in the last problem. It's the first term over 1 minus r. And a lot of you put the wrong thing down for the first term.
Yeah, I misread it. I thought it was the one.
I mean, easy. I mean, no big deal. Like, I'm not judging you. So let's talk about the comparisons. Okay, so the paper, the homework from problem. So I worked all those out the other day, yeah? We worked all those out, and so you had the solutions. But if you have questions on those, you still very much could have questions on those. So what question do you have? Yeah.
Okay, I'm just having trouble with like the limit comparison, like knowing what to compare it with. Like for like number 5, like I tried to do that like instead of.
So number 5 would be one that you might have, yeah. I mean, I get number 5. It was out there, right? Because it doesn't look like any of the other ones, and you can't reduce it, quote unquote, right? So on something like number 5, if you're going to use the limit comparison test, I would pretty much just choose two different things max. And if they didn't work, then move on. All right? And I would choose for number 5, 1 over n, just because I see 1 over n in there. All right? That's why I would choose it. If 1 over n didn't work, you did the limit comparison test and you got something that was 0 or infinite, and that didn't work, then I might try 1 over n squared. And if that didn't work, I would probably move on and try and use another test. Okay, the limit comparison test. I mean, it should be pretty quick. Like it shouldn't be one that where you're trying multiple different things and then it's not working. Because if that's happening, you probably want to use different tests. Now, I will tell you the example that we did in class that was similar to number 5. You go back and look at your notes. The last one that we did, we started this example, but we didn't finish it. It was 1 minus cosine of 1 over n. Right? And we didn't finish it. And I made that one up during 3rd period because I knew number 5 was on the sheet. But I didn't want to give you the exact problem because number 5 wanted to give something similar, so I did cosine of 1 over n. But the problem with just cosine of 1 over n, when I made that up, I couldn't just use this. Why? I mean, I could give you that problem. Does that converge or diverge? As in, I didn't give you a starting value, but cosine 1 over n, does that converge or diverge? What happens as n goes to infinity? That's the cosine of 0, which is 1. Which means the terms of that series are approaching 1. They're not approaching 0, so that doesn't converge. So you wouldn't even need the limit comparison test. So when I thought do this, I was like, oh, okay. So I'm going to give them this series, so to use the limit comparison test. This is what I gave you, right? And I said, okay, let's do limit comparison test with 1 over n. Why are we choosing 1 over n? Well, because it's there. Right? And when we went through this, and maybe we put the 1 over n on top. I don't know. It doesn't matter which one goes on top. Okay? We got this. And we said, okay, as n goes to infinity, this is now going to 0. That's going to 0. So we're going to do L'Hopital's rule. So we do L'Hopital's rule. We say, oh, the derivative of the numerator is sine of 1 over n times the derivative of 1 over n is negative 1 over n squared. The derivative of that denominator is negative 1 over n squared. Okay? Those guys cancel, and you're left with this. And what's the answer to that limit? Nope. The answer to that is not infinity. The answer to the one we got in class was infinity because we had flipped those. This is actually, as n goes to infinity, this is going to 0. Sine of 0 is 0. Okay? Now, when we did that same limit comparison test, but we flipped this, which is what we did on Monday or Tuesday, we flipped that, we end up getting 1 over 0 instead of 0 over 1. Right? 1 over 0 is approaching infinity. But in order to use the limit comparison test, the answer that you get to the limit has to be finite and positive. 0 is not finite and positive. Right? And infinity is obviously not finite and positive. So the limit comparison test, the test fails. Okay? We cannot use 1 over n for this particular one. The one on your homework, you could. Okay? The one on your homework, you could use 1 over n. The one on your homework diverged. Right? So what are we going to do here? What would we do here? If you were listening to what I said a minute ago, I said, okay, when you're doing the limit comparison test, try a couple of different ones. If they don't work, then move on. Yeah. It doesn't.
Well, that's the exact same thing. And you get 0. But you get infinity.
What?
It's like the exact same, except this is on the top.
I know, Billy. When we did it on Tuesday, we flipped this.
Yeah. So
And we didn't get 0, we got 1 over 0.
so it does matter where if it's on the top.
No, because we got 2 different results for the limit. However, in order to use that result and make a conclusion with the limit comparison test, the answer has to be finite and positive. If I get 0 here or 1 over 0 here, neither one of those are finite and positive, so it still didn't matter. Does that make sense? So what are we going to try now instead? Pick a p-series that converges and go with that. What's an easy one? I mean, this we picked a p-series that diverges. Pick one that converges. 1 over n squared. Okay, try that one. So now we're going to do a limit comparison test with 1 over n squared. Are you ready? So we're going to do the same thing. 1 minus cosine of 1 over n over 1 over n squared. We're going to compute this limit. Right? Okay. Well, as n goes to infinity, we're still looking at 0 over 0, yeah? So what are we going to do when we have 0 over 0? What? Yeah, the hospital rule. Every now and then you get a little. Ooh, my microphone fell down. Okay, so if we lope it, so we take the rate of change of the top and of the bottom. Okay, so now that's the derivative of the top. What's What's the derivative of the bottom? This is n to the negative 2. So that's negative 2 n to the negative 3. Yeah? And now you got to put on your algebra pants. Okay? I think these qualify as algebra pants. You got to simplify this. So over here, I'm going to be like, okay, sine of 1 over n times negative 1 over n squared. This is like 2 over n cubed, right? So when I divide by 2 over n cubed, that's like multiplying by n cubed over 2. Or negative 2, I guess. Now, how's that going to simplify? The n's cancel, and I'm going to end up with negative 1/2 here times n. Just put parentheses there, I guess. Yeah. Yes, thank you. Oh, that's right. Good call. So now I'm over here. Ready? So I'm left with sine of 1 over n times n over 2. Okay, so let's do the limit. What happens? What you get? As n goes to infinity, what's this going to? They canceled. As n goes to infinity, what's sine 1 over n going to? 0. As n goes to infinity, what's n over 2 going to? Infinity? Right? So 0 times infinity. Not 0. It's indeterminate. 0 times infinity is indeterminate. So we're going to have to do L'Hopital's rule again. But in order to do L'Hopital's rule, we need to write it as a fraction. So how can I rewrite this? I'm going to take the 1/2 and stick it outside the limit. How can I write sine of 1 over n times n as a fraction? I can write it like this. Sine of 1 over n over 1 over n. Yeah? This definitely requires some big algebra pants. Okay. So now, do you still have indeterminate form? Of course you do. Sine of 1 over n, that's going to 0. 1 over n, that's going to 0. So now we've got 0 over 0. Right? Guys, that's why 0 times infinity is indeterminate. Because if you you can sometimes rearrange that and end up with 0 over 0. Like that's we didn't change the value of anything here. We just rearranged things algebraically. So what do? L'Hopital. Every now and then I get. So what's the derivative of the top? Cosine of 1 over n times negative 1 over n squared. Because of the chain rule, what's the derivative of the bottom? Negative 1 over n squared. Oh, look at that. Those cancel. So now we're left with 1/2 times the limit as n goes to infinity of cosine of 1 over n. And what's that? As n goes to infinity, what's cosine of 1 over n going to do? Approaches 1 times 1/2. That's 1/2. Hey! What does that mean? That's finite. That's positive. So these two series do the same thing. Now, what was the series that we were comparing with? 1 over n squared. So this guy now converges by the limit comparison test with 1 over n squared. Okay. So we ended up having to do L'Hopital's rule twice to get that. That's what your boy Odell said last period. Like, I was like, what would you guys think to try? 1 over n squared? Would you want to try that? Tom was like, yeah, and Odell was like, no, it's a lot of work. Yeah.
So, did you know, like, if you did this with something that converted and you got 0 or infinity, would you just tell by then that it diverged? Like, like for this one, we did it originally with 1 over n, and we did that diverge.
No, because the test failing doesn't mean that it does the opposite. Okay, that's a good question. The test failing means the test fails. Okay. And like I said, if you try 1 over n, and then you try 1 over n squared, and it fails both times, then you're going to need to use some other test. But I can tell you right now, that probably isn't going to happen with the problems that you're going to see with me. Okay? Okay, other questions? Other questions? Jimmy, what was yours? Was it this one?
Yeah.
Yeah. This was the common one because it just looked weird. I mean, the one on your homework, sine of 1 over n, like, what am I supposed to do with that? Okay? Because it didn't reduce down to one that you liked. It didn't reduce down to 1 over n squared. It didn't reduce down to 1 over n. Okay? So let's kind of outline sort of what's the next week and stuff. So like I told you, there's like 50-50 chance I won't be here on Friday of next week. I think that day, Friday of next week, you're going to have your test on tests. Okay? You're going to have a test on tests. We'll probably have another quiz before then, like probably Monday or Tuesday. Now Tuesday is an air day, so we probably wouldn't have it on Tuesday. Is Thursday an air day? Yeah, maybe we would have our tests or our other quiz on Monday, just because I don't know that I want to give you a quiz on an air day when you're coming in. It's silly, seems silly to come in to take a quiz. But I'll figure that out in the next 48 hours. But we'll be finished with we only have 2 more tests to learn. And so we'll be finished with the tests by then. So if I'm not going to be here, that's probably the tests. And then once we have our test on tests, then we're going to start talking about the other branch of infinite series, which is polynomials. So yeah, we're in good shape. So we're going to learn a new test today. This is the easiest one out of all. Like, by far. The easiest one. What did you say? No, the ratio test is probably it's difficult to say it's the most difficult, but it's the most work. No, the alternating series. Why is the ratio? That's not why the ratio test is my favorite. The ratio test is my favorite because it pretty much works. It works for just about most of the series. You might be saying, well, why didn't we just learn that one? Well, it's a lot of work, and sometimes you can get the same answer with significantly less work. The alternating series test is what we're going to learn today. This is the easiest one. So it'll probably be your favorite. And technically speaking, this isn't even a test, but we'll call it a test. Okay? So the alternating series test. So but first we're going to tell you what an alternating series is. An alternating series is this. So an alternating series is a series of that form, where the terms are going plus minus, plus minus, plus minus, plus minus. We have a positive term. See what? Oh no! Plus minus, plus minus, plus minus, plus. Okay? It's something that, you're going to have something in your sequence that defines your series that's going to generate a negative of, plus minus, plus minus. And oftentimes, that's going to be a -1 to an odd power. A -1 to an odd power is going to generate a plus minus, plus minus. You guys see that? Why that would happen? So it's real simple. If a series is alternating, an alternating series converges if this is true. An alternating series converges if that's true. But it has to be alternating. So what is that saying? What is that saying? This, in some ways, contradicts something that we learned before. Maybe. Not sure if contradicts is the right word, but sort of conflicts with something that we learned before. What is that saying? Billy, what do you think that's saying? If the terms approach 0. Okay? If the series is alternating, plus minus, or minus plus minus, plus minus plus, that doesn't matter. If the series is alternating and the terms are going to 0, it converges. It's that simple. Okay? It's that simple. Okay? Let's look at an example of one of these babies. So if we were to write out the terms of this, we would write out the terms like this. 1 plus -1/2 plus 1/3 plus -1/4 plus 1/5 plus -1/6 and so forth, right? Agreed? And that obviously can be thought of because we understand how math works. Like that, right? You agree with me? This is probably one of the most famous alternating series of all. It's the alternating harmonic series. Okay? Does that converge or diverge? Why? The terms are going to 0 and it's alternating, right? You got to make sure we say it's an alternator. Okay? So terms are going to 0, right? And it's alternating sign. Converges by the alternating series test, okay? AST. But this series that we're talking about here, this alternating harmonic series, is very special. It has a special property, okay? I want you to look at this series. Consider this. What am I doing there? I'm sticking that series inside of an absolute value. Which is effectively, if I read out the terms of that, it's just 1 plus a half, plus a third, plus a fourth, plus a fifth, yada, 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 right? Which is effectively like saying this. It's just chucking the -1 to the end and doing that. All right? See what I'm getting at there? Does that series right there that's equivalent to, does that converge? No. This guy diverges, right? He's the harmonic series. The regular old harmonic diverges. P series, P equals 1, right? So what's going on here? This series right here converged, right? But he only converged because his terms were alternating. If I took the absolute value of all the terms, it diverged. You follow that? It's like we've got a series that converges when it's an alternator, but doesn't when it's not alternating. It diverges when it's not alternating. Okay? We have a term for this. It's called conditionally convergent. Okay? It's conditional convergence or conditionally convergent. One's on whether or not you want to make it an adverb or an adjective. It's this idea of conditional. What do we mean by that? Okay, we're going to put it in sort of math speak. A series is conditionally convergent or conditionally converging if the series is conditionally convergent if it converges, but it diverges when you take the absolute value of the term. Right? And the antithesis of conditionally convergent is something called absolute convergence. Absolute convergence is this. A series is absolute or converges absolutely. Let's say it that way. If you take the absolute value of the terms and it converges, so it's absolute convergent if it doesn't matter if it alternates or not, it's still going to converge. Alternating harmonic, conditional. It won't converge. It's not alternating. Okay. Now in a second, we're going to look at some examples and show you how to do this. Yeah.
So if it's an alternating series, but it doesn't approach zero.
That's exactly right. And in fact, Billy, if it's an alternating series and the terms don't approach zero, it diverges by the nth term tests. Right? I mean, if the terms are not approaching zero, period, your series diverges, no matter what. It's just now we've sort of softened that a little bit. It says, okay, well, they can, if they're approaching zero and they alternate, we can conclude that it converges. But just because they approach zero, if they're not alternating, it doesn't necessarily mean you converge, unless you're alternating. All right?
So it's possible to have a series that's alternating that like converges will not approaching zero. I feel like that's really bad.
Is it possible that a series that's alternating that converges whose terms are not approaching zero?
Yeah, because like I feel like
No, that won't happen. I mean, a perfect example of that is this series right here. Like, you might think that series is going to converge, but it's not going to converge because it's either 1 or -1. It doesn't. The sum is not.
I was thinking like it's a thing where it was alternating back and forth. The difference of it up and down is what you're gonna have to. Or like, I don't know.
But the only way that difference is going to approach a number is if the terms themselves are getting smaller. Now, I'll be honest with you. This idea of absolute and conditional, we're not going to care a ton about over time. Okay, you're going to have to play with it on your homework, but over time, we're not going to care about it a lot. The one interesting thing, and we're going to do this tomorrow. Okay. The one interesting thing about a conditionally convergent series, and I think I told you this already, is that you can take the terms of a series that is conditionally convergent and rearrange them and make it add up to different things. Okay? So for example, and this is the one we'll use tomorrow, okay? We'll show tomorrow that I can take these numbers right here. Okay? I can write them out this way and add them up. And I can show you this is equal to such and such. But then I can change the order in which I add them up and show you that it adds up to something else. Which should blow your mind. Because it completely contradicts the idea that addition is commutative. Right? I mean, didn't you learn that pretty early on in your life? Like, oh, a plus b equals b plus a. That's not true if you're adding up an infinite number of a's and b's. Okay? That's kind of whack. All right? So we'll do that tomorrow, and it's kind of crazy. But right now, let's just kind of give you some examples of this so you can make sure we know how to do our homework and we have a pretty good concept of absolute and conditional and alternating and all that jazz. All right, so you ready for a couple examples? said, most of the time, the alternating is going to be generated by some odd power of -1. Okay? There are other ways to generate a +1, -1, +1, -1, but I want you to discover those in your homework. I want to just tell you. You fun math. So your task is to tell me if that series converges first, and then if it does converge, whether it's conditional or absolute. Are the terms going to 0? Billy, are the terms going to 0? You bet your butt they are, right? Are they alternating a sign? Yep. So this guy converges by the AST, right? Now, friends, is it absolute or conditional? So in order to do that, we must do this. Which is basically the same thing as doing this. Right? I mean, taking the absolute value of the terms is basically like chucking the -1 thing. So does that guy converge? Now here's where we'd have to use one of our other tests, right? But I will tell you when you're determining absolute or conditional. I don't care if you do the hand wave test. I don't care if you just do the all that reduces to this. I know what it does. So can you just look at that and tell me what it does? What does it reduce to, quote unquote? 1 over n. What does 1 over n do? Diverges. Okay. This diverges. So this is conditional. Yeah? Because we converge as an alternator, but we diverge when we took the absolute value. That's conditional.
This one, with that like improper simplification, no, that will be the same.
Do you say what?
If you use improper simplification.
Yeah. I mean, that's what I'm saying. That's called, I call that the hand waving or the reducing test. Okay? But what about this one, friends? -1 to the n over n factorial. Okay? So maybe you're looking at that and you're saying, okay, are the terms going to 0? Yeah, they're going to 0, big time. Okay? And they're alternating a sign, right? So we know that's a converger by the alternating series. Is it conditional or absolute? So what we have to consider is this series. Which is essentially this series. Right? Now that series you might be panicking, like, oh shoot, I don't know. What do I do? Okay? Can't use the integral test on that because 1 over n factorial doesn't have an antiderivative. Right? Nth term test doesn't work. It's not geometric. On this one, we can do a comparison test. And this one is actually real easy to do a direct comparison test because pick your favorite p-series. It doesn't matter. Pick your favorite converging p-series. 1 over n squared. This guy right here is big time less than 1 over n squared. Maybe not after the first 2 terms, but it will be soon. Okay? Because 4 factorial is way bigger than 4 squared. Okay? So what does this guy do? 1 over n squared converges, which means this converges, which means this is absolute. Okay?
So if we see one of our integral, we know that convergence would be like.
I mean, it's almost anytime you have a factorial. If you have a factorial in the denominator and nothing else in the numerator, yeah, I mean, it's not even close.
You need another factorial in the numerator.
Now, if you've got factorials in the numerator, then we got a different discussion.
Yeah.
Which that's going to come when we do the ratio. See you later, friends.
Isn't this greater than?
No. N factorial is greater than n squared, but not 1 over n factorial.
So I did actually reach out to the admission. See what they want, and they basically just said they're not.
Oh, really?
Yeah, which is like. So like we leave it up to the school to decide what's best for the students.
Did you dress up for Nick's birthday?
Yeah.
Really, like what their requirements are for like even like lunch, like having math or calculus, having 1 year of physics, having 1 year of chemistry, 4 years of English.
Which,
That's not.
yeah, you've already got that.
I don't have English now.
Or, well, you will have that.
Have you and Hip used the fishing rods we got you yet?
Hip gave them to Mr. Sullivan because he's got 2 little girls.
Yeah.